Good morning to my dear educators. Welcome back to my project Art Integrated Learning Project on Mathematics for Class 12 Science based on the topic Function in the Real World and in Real Life Problems. I would like to convey my heartfelt thanks for your great patience, interest and eagerness to spend your valuable time till the end of the class. I am abide by your sincere and worthy suggestion in improvising and doing the rectification, which would be the great source of my learning aspect. Art Integrated Learning Project on topic Mathematics, Class 12 Science, prepared by Makan Sousa. What is art? My first question is that what is art? Art is the creative expression of an individual. This expression is in the form of verbal or enactment or visual that has the potential to communicate the human thought. What is art education? Yes, art in education is an educational research and practice informed by investigations into learning through art experiences. In this context, the art can include performing arts, education, dance, drama, music, literature and poetry, storytelling, visual arts, education in film, craft, design, digital arts, media and photography. Art and visual. Okay, so here is a design and which is give clearly depicting the mathematical patterns and geometrical patterns in the form of different structure, geometrical structure through art and visual. This is another geometrical structure and patterns which has deep relationship with the concept of mathematics, geometry. Art integrated learning is a strong curricular approach to teaching and learning activity based on the collaboration between the teaching of subject with the teaching of art. Objective of art integrated learning reduces burden of curriculum and enhances the thoughts of mind. Creates teaching, learning act joyful, enables to deliver and acquire the knowledge through the artistic expression. Is necessary because when art is integrated with education, it helps the child apply art based inquiry, investigation and exploration, critical thinking and creativity for a deeper understanding of the concept. How does the art integrated learning is effective? Visual images are closely related to mental images. Art makes these images clearer and more concrete. The experimental aspect of the art helps one go deeper into the other. Mental imagery is an essential part of the thinking process elements of life. Art is related to our visual experiences. According to Julia Marshall, professor of art education, San Francisco State University, USA says, the focus of art is not the color. The focus of art is not the color of choices, but rather the meaning, thinking, and reasoning that the artistic process generates. What is art integration in mathematics? Art integration in mathematics provides an engaging and effective way to achieve standards in both math and geometry and visual arts. Students develop math skills of defining, identifying, classifying and describing the shape, size, color and location of geometry figures. Onion tabulation, tabuliform plants, pattern nature. This is another natural design created by the nature in plants. It is clearly give the information and it has deep interaction with the concept of geometrical structure and many mathematical aspects. Geometrical pattern. This is also another geometrical pattern, okay, and through the means of arts and visuals. Application of geometrical shapes and design in construction, buildings, apartments, temples, churches, etc. So it completely based on the mathematical concept, geometrical concept, study of the different shapes and structures, which has deep interaction with the concept of mathematics. So our project on mathematics function in the real world and in real life problems. Abstract. The world function is not merely associated with mathematical concept. It is in fact related in every real life in the world. It has deep interaction with nature and life. As we all have been created by nature and we have certain responsibility towards it. A child has certain responsibility towards his parents. As without carbon dioxide, a plant is never possible. Oxygen is never possible without plants. We need to reciprocate in an adequate manner to handle our responsibility towards our livelihood where we work for our life. Every action has equal and opposite reaction. This scientific statement of Newton's gives a clear indication to the close interaction to express the meaning of the function. The function is considered the building block for arts, designing, predicting natural disasters, curing diseases, understanding world economics, and for keeping hairpins in the air. Thus, function is considered as the real world and is inevitable in solving real life problems. What is function? It is a mathematical term and it has deep relations with the nature and in various fields. So, according to mathematical concept, a function relates an input to output. It is like a machine that has an input and an output. So, function is just like a machine that has an input and an output. And the output is related somehow to the input. So entirely the output is entirely dependent upon the input. It means the output and input are related and interrelated to each other. This shows the function is such nothing is the interrelationship between the two objects or more than two objects. Fx is the classic way of writing a function. The classic way of writing a function which is denoted by fx, which is known as the function of x. We will see many ways to think about function, but there are always three main parts: the input, the relationship, the output. Sometimes there is no function name. Sometimes a function has no name, and we see something like y is equal to square. But there is still an input x, a relationship. What is that? Y is equal to square. Here x is the input and y is the output. And the relationship y is equal to square is the processing and is the function and is relationship between the input and output. Function in mathematics an expression, rule or law that defines relationship between one variable which is known as the independent variable and another variable which is known as the dependent variable. Functions are ubiquitous in mathematics and are essential for formulating physical relationship in sciences. Function machines. The function machines metaphor. You put some object into its input funnel. If the input object fits into the funnel, then the function machines will process that object and turn it into some other object which comes out in the form of output. This is the function machine. This is the input. This is the function machines. This is the output. And this is the relationship, the processing between the input and output in the function machines. Composite function. Composite function, when a function is followed by another, the result is a composite function. A composite function is created when one function is substituted into another function. Suppose, for example, here fx is equal to 3x plus 2 and gx is equal to x plus 5. So f of gx is called f of, in place of gx we can write x plus 5. Okay, so now it is given that fx is equal to 3x plus 2. So in place of x, now x plus 5. You can, in place of x, okay, we can write x plus 5. So 3 will into x plus 5 plus 2, which is 3x plus 15 plus 2, which is 3x plus 17. Suppose you are finding g of fx. G and fx is 3x plus 2. Here fx is the independent variable, which is known as the input. And 3x plus 2 can be put in the value of gx in the function gx is equal to x plus 5. So in place of x, we can write 3x plus 2. So 3x plus 2 plus 5 is equal to 3x plus 7. Hence, g of fx is equal to 3x plus 7. This is another interesting concept, mathematical concept between the composite function, between the function f and g, between the function fx and gx. So composite function given two functions f and g, where x is the domain of g and g is the domain of f. So f of gx is equal to f of gx, f gx, and g of fx is equal to g of fx. Here gx is the domain of f. In the function fog x, this is also known as fog s. So in the okay, so gx is known as the domain of the function fx, and fx is known as, which is known as input. Gx is the input or domain of the function f, and fx is known as domain of the function g in the function of x, which is g of x. So here is the Venn diagram of the composite function. Here a, b, c are the three sets, and f is a mapping or function from a to b, and g is a function from b to c. Okay, so it is function of f of g and g of f. It is an example of diagram, Venn diagram, which is clearly indicating, explaining the composite function through Venn diagram. Here is the composite function machine. So domain, function machines, another function machines, and codomain. There are two function machines. One is f, other is g. Domain, range, codomain. Domain is known as, input is known as domain, which is known as the independent variable, the value of the function, the value under which the value of the function is determined. This is known as the input or domain of the function. And this is the output or range of the function. What is output come out? The output that come out is known as range of the function. So naturally in the function y is equal to fx, x is known as the domain of the function, and the value of the function is y is known as the range of the function. Types of function: many one function, onto function, otherwise known as subjective function, into function, one function, or injective function. Here, one person, one passport. It is clearly example giving the relationship between the one function. It means for every person has one passport. It means for every value of x, we shall get one value of y. For every single input, we shall get the single output. This is clearly giving the relationship between the one function. So one function is a function that for every unique value of x, there is a unique value of y. For unique value of input, we shall get the unique value of output. For unique value of independent variable, we shall get the unique value of dependent variable. This is another example of Venn diagram of unknown function. So A and B are the two sets. For every element in the set A is assigned with an unique element in the set B. Here 1 is assigned to A, the element 2 has been assigned to B, here 3 is assigned to C, and 4 is corresponding to D. So every element in the set A is related to unique element in the set B, which is known as one-one function. So a function f(x) x approaches y, x to y is said to be one-one function or injective function if the images of distinct element of x under f are distinct. For every x1, x2 belongs to x, fx1 must be equal to fx2. Implies that x1 must be equal to x2. We can say every element of the codomain is the image of only one element in its domain. Human relationship with the organ. Heart, human heart. And this is clearly indicating the example of one-one function. Yes or no? Right? Yes? Here is the diagram for you. Education field, medical field, business field, science field. We need the use of computers. So computer is useful in conducting the many functions in our society. A computer acts as a source of communication with various fields, which is known as many-one function. Many-one function, if any two or more elements of a set are connected with a single element of the set B, then we call this function as a many-one function. Here in the Venn diagram, here input and output, here 1 is assigned to 4, 2 is assigned to 4 and 3 is all assigned to 4. It means this is a what kind of function? Many-one function. Onto function. Onto function or surjective function from the set A to set B. Onto function if each element of set B is connected with the set of element A. It means that every element of the set B must be connected with the unique element of the set B. Unique element in the set A. Here is the diagram. Can you say is it onto function? You see, the element B in the set, second set, is not assigned. That's why it cannot be onto function. Every element in the set, each element of in the set B must be assigned with unique element in the set A. This is the example of the surjective function. But since the element B is not assigned to any element in the set A, so it is not an onto function. Onto function, you see. This is the clearly giving the example in our natural surroundings. Are you guessing anything else? Yes? Carbon dioxide, animal and plants are interdependent. This shows how the function is related in our nature. So nature gives a clear indication about the function. So function in the real world, the function in the real world is inevitable because there is an interdependence, interrelationship between nature and the animal in the universe, in the world. This is giving a clear indication and understanding about the nature and the function in the real world and our real life problem. Because without carbon dioxide, plant cannot survive and animal cannot survive without oxygen. Water, sunlight, soils are inevitable and are interdependent. Another function is known as inverse function. This is the diagram of the inverse function, graphic diagram of inverse function. An inverse function is a function that undergoes the action of another function. A function z is the inverse of a function f. If whenever y is equal to fx, then x is equal to gy. If y is equal to fx is equal to x squared minus 4x plus 3 is the graph of this function, then g is equal to f dash x is equal to 2 plus x plus 1 root over is the graph of the inverse function. Here is another indication example of the inverse function. Letter f, inverse function. If two functions are mirror image of each other above the line y is equal to x, they are inverse to each other. Inverse of reflection is the same reflection. Beauty of inverse function. Yes. So how natural beauty gives the indication of the idea of the inverse function. Mathematics in the real world we are studying. Yes, we can get the clear indication, clear understanding, clear realization about the beauty of the inverse function. Derivative is the rate of change of function. Derivative instantaneous rate of change. The derivative of function f at a specific value of x, says a, is the value given by f dash x is equal to f dash a is equal to dy by dx. This is the derivative of y with respect to x, which is limit of f a plus s minus f a divided by h, where h approaches 0. So the derivative function f as a function of x is called f dash x and is given by f dash x is equal to dy by dx, limit of f of x plus s minus fx by h, where h approaches 0. Use of the function in derivative. Application of derivative function. Filling of the drum. When the water is filling in the drum from the water tap, so the volume of the water is increasing. At what rate the volume of the water is increasing? If the radius of the cylindrical vessel is given 1.2 meter. Yes? So at what rate the height of the volume is increasing? At what rate the height of the water is increasing in the drum? And what is the speed of water? This is also clear example and application, an interesting fact of the function in the real world by using the function in the derivative of the function. This is another part of calculus, all of you know. Application of derivatives, rate of change of volume and height filling cylindrical vessels is the application of the function in the real world. We can measure the height of the water is increasing, at what rate the water is increasing, and where the volume of the water is increasing. If the radius of the vessel is given. Increasing function. So what is increasing function? Definition of increasing and decreasing function all of you know. A function f is increasing on an interval if for two numbers x1 and y1, two independent variables. There are two independent variables. For any two independent variables x1 and x2 in the interval, x1 is less than x2 implies that fx1 is less than fx2. It means if the value of x is decreasing, the functional value is also decreasing. A function f is decreasing on an interval if for any two numbers x1 and x2 in the interval x1 is less than x2 implies fx1 is greater than fx2, otherwise known as decreasing function. You can understand the tangent, the slope of the tangent. This is clearly indicating the slope of the tangent increasing from left to right. That is why it is an example of increasing function. From the graph you can understand. At this point, this is the tangent of the function and the slope of the increasing. It means if x1 is less than x2, the functional value is also decreasing. Fx1 is less than fx2. Decreasing function. You say the tangent, the slope of the graph is decreasing at this point. So a function is decreasing on an interval, in an interval, if fx1 is greater than equal to fx2. For any 2 points, x1 is less than equal to x2. A function with a graph that moves downward as it is followed from left to right. The graph of the function falls downward from left to right. And you see the slope of the tangent becomes negative. And the rate of change of function will be negative. Yes? Beauty of nature, increasing and decreasing function. It is another interesting and wonderful natural phenomena from increasing and decreasing function in our real life and day-to-day life from our nature. You see, this function is increasing and here function is decreasing and increasing. So at this point, this is known as the turning point of the function. It is a point where the function change the direction. So almost everything most people think of mathematics involves as a function. In fact, the function is used for any real life purpose and is used in every sphere of life and used in solving real life problems. Thank you for your paying your precious time. Visit again.